All right, good morning, class. This is Monica, and today we'll be talking of MSE 030 Cloud and Infrastructure Security, and this is session 1 regarding it, part 1. ठीक है, so let us just get started. कि what is cloud actually? What are infrastructure actually, and how we deal with these things? So let us just get started. See, class, what is cloud computing? Cloud computing is anything, where we are delivering the services over the internet. Like, internet plays a very important or it plays a crucial role while we deal with cloud computing. And in cloud computing, what we are doing, we are simply delivering these services. हम लोग सिर्फ services को deliver करते हैं. ठीक है, then it is basically categorized into three types. Now it is actually trifurcated into three types. One is IaaS, another is PaaS, and then SaaS. This stands for infrastructure as a service, platform as a service, and software as a service, right? These are the three things which keep revolving when we talk of cloud computing, class. Then a cloud could be private as well as it could be public. Cloud can be private or it could be public. Now, by public, I mean that I am going to sell the services to anyone who is on the internet. Now, for example, if I am taking, the help of certain cloud where I want to keep my data, so that could be public also, that could be private. Now, public is not restricted, it is open to any public. And in when I'm dealing with the when I'm talking of the private people, then that means there it is restricted. So a private cloud is a proprietary network or a data center that supplies the hosted services to a limited number of people. Now that is important here, with certain access and permissions settings also. प्राइवेट और पब्लिक जो गोल है आपका क्लाउड कंप्यूटिंग का, दैट इज to provide easy and scalable access to the computing services and your resources, right? Then cloud infrastructure, by cloud infrastructure I mean that it is going to involve both the components, the hardware and the software components, and that is for the proper implementation of the cloud computing model. You can consider it as a utility computing और ऑन डिमांड कंप्यूटिंग ऑल्सो. क्लाउड कंप्यूटिंग को हम लोग कुछ अपनी यूटिलिटी वांट टू यूटिलाइज समथिंग, so we can call it as utility computing, or it could be on demand computing when we are demanding something and we want something, so with the help of cloud we can access it. Now why cloud computing is named so? So it is named as such because the information is being accessed and it is found remotely in the cloud or the virtual space. See, class, when this is my mobile, computer system, and if I'm having certain space here, by cloud I mean that this space is not present actually in my system. That is something we are hiring from some other thing, like we are hiring or we are asking some other place to give it. So that is something related to the cloud computing. So cloud computing is named as such because the information is being accessed and it is found remotely in a cloud or a virtual space. कोई cloud या कोई virtual space में हमने इसको रखा होता है. Now the companies that provide the cloud services, they enable the users, अगर वो चाहें तो यूजर्स अपनी फाइल को स्टोर भी कर सकते हैं, एप्लीकेशंस को स्टोर भी कर सकते हैं ऑन द रिमोट सर्वर. दैट मीन्स यू आर नॉट हैविंग दैट पर्टिकुलर सर्वर, द सर्वर इज विद समवन एल्स, and if you want to utilize that thing, you can utilize it and you can access your internet via what? Via internet. Like you should be having the internet connection. This means that the user is not required to be in a specific place to gain the access, or allowing the user to work remotely. Cloud computing takes all the heavy lifting involved in crunching and processing the data away from the device you carry around or sit and work at. Right? So that is all about cloud computing. What is cloud computing? Cloud computing may we are hiring or we are accessing the services over the internet. Right? Then what are the variety of cloud services, or what are the types of cloud services? So regardless of the kind of services, cloud service providers they provide the users with a series of functions. Like you can utilize it for email, You can do it, use it for the storage, for backup, for data retrieval, for creating and testing the applications, for analyzing the data, for streaming of the audio and video, and for delivering the software on demand. So we have a variety of things that we can do with the cloud things. Then there are certain deployment models also involved here. So there are variety of types of clouds, each of which is different from other. Public cloud, just now I've told you, they provide their services on the servers and the storage on the internet. They are operated by a third party companies who are going to handle or control the entire hardware, the software, and the infrastructure. The clients access the services through the accounts that could be accessed by just and about anyone. But when we talk of the private clouds are reserved for the specific client, usually a particular business or an organization. For example, if we are talking of the Ignou only, so Ignou can also have a it can store its complete data in a private cloud. Now, private cloud, why? Because it is one business or one organization, so it can hire one private cloud for its use. Now, the firm's data service center may host the cloud computing service. Then, many private cloud computing services are provided on the private network. Then there is another thing, third thing, that is the hybrid cloud. So, as the name implies, it is the combination of both public and private services. That means here the user is going to get more flexibility and it is going to optimize the infrastructure as well as it is more secure also. See, just for the sort of distinguishing, we have certain characteristics like demand for in-house infrastructure. Like in public, we do not need the infrastructure; it is not required. In private, it is mandatory. In community, it could be shared, and in hybrid, it is required for the private cloud. So that means here in hybrid also it is required. Then ease of use. Public wala, it is very easy to use. Then here it requires an operational IT staff. Again, IT staff. It is more complex, so it requires more than one deployment model. Cost, this is affordable, this is high cost. The cost is distributed among the organizations. And here in hybrid, it is cheaper than private cloud and it is costlier than public. Then let's just talk of the security. Public is less secured. Here the security is better. Here also it is better. Here also it is higher. Then when we talk of ownership, so here the cloud service provider is the only owner. But when we talk of the private thing, here is a single organization who is going to take the charge, who is the owner. Then here the multiple organizations are involved, so they are involved and they are, their own owners. Then we have hybrid. We have the cloud service provider for the public cloud and the organizational for the private cloud. Then who is managing these things? Like when we talk of the public thing, then it is being managed by the cloud service provider also. Here it is managed with a certain staff, operational staff. Here also this is certain staff among multiple organizations. Here it is that here it is providing certain staff for the public and private. Scalable, how scalable it is? Here it is very high scalability, it is limited, and here also it is high. So just for the sake of understanding, we have this table that you people can refer. What all we have done till now? अभी तक हमने क्या समझा क्लास? क्लाउड कंप्यूटिंग होता क्या है? How do we define cloud computing? Then cloud computing K, there are certain services that are being provided and basically it is of three types. One is public, what is it? One is private, what is it? And another one is hybrid, what is it? Right? Then we have the services of cloud computing. Just now I have told you that is SaaS, IaaS and PaaS. Now what are they? See class, when I am talking of software as a service, here it involves the licensure of the software application to the customers. Licensures are typically provided through a pay-as-you-go model or on demand. Now this is important. Now what is happening in a software as a service, you should be having internet, this much you know. Now when you have the internet, you can borrow the software if you feel like, and while borrowing you need to get the licensed software, for example, MS Office. Now that is a licensed software. So here you can pay as you go or on demand. Like when you're dealing, there would be certain pop-up messages. आपको MS Office में pop-up messages देता है, वो बोलता है आप हमारा जो ये आपका ऑफिस है आप इसको खरीद लीजिए, buy it. So that is something being categorized as software as a service. Then infrastructure as a service. So it involves a method of delivering everything. आपको सब कुछ मिल जाएगा from operating system to servers to storage through the IP based connectivity as a part of on demand service. So clients avoid the need to purchase the software and instead they procure these resources in an outsourced on demand service. Examples would be IBM का cloud, माइक्रोसॉफ्ट अजूर है, ये सब लोग क्या कर रहे हैं कि इंफ्रास्ट्रक्चर को बाय कर ले रहे हैं, सारा कुछ ऑपरेटिंग सिस्टम वगैरह, दे डू नॉट हैव टू deal with the downloading and installing part. Everything is being there when we talk of infrastructure as a service. Then platform as a service is the complex of all these because it is following certain similarities with SaaS, and there is a difference also that instead of delivering the software online, it is actually a platform for creating the software. If you want to create a software, you can create a software and later on that would be delivered via internet, right? Examples would be salesforce.com or Heroku. You use the thing, you use the platform, etc. things, and later on it would be provided to you and you can buy it. So you can say here, yes, the money factor is involved because you need to buy it. Here also, when the license is there, the money factor is involved. But when you are, sharing the infrastructure as a service, so in that case, you are not involving any money. So that is something, you can say these are certain services that are being provided by the cloud things. Then what are the characteristics why we are moving towards cloud computing? Because the first characteristic is there is on demand self services. On demand self services, the cloud computing services do not require any human administrators. Whatever you want, you can manage it, you can do it. Then broad network access. The network access is very good over here. Then rapid elasticity. The computing services should have IT resources that are able to scale out and in quickly as and on need basis. So it is quite elastic. Whenever there is requirement, you can use it. Then resource pooling. Now by pooling, I mean what? Sharing. So resources could be shared, the IT resources like the networks, like the servers, like the storage, the applications. They are shared among multiple applications and they are occupant in an uncommitted manner. So multiple clients are provided service from the same physical source. Then there is a measured service. Now the resource utilization, कौन कितना resource use कर रहा है, that is also being tracked for each application and the occupant, and then it will provide both the user and the resource provider with what is the account or how much the resources have been used, and accordingly the billing is being monitored. Then there are certain advantages of cloud computing. For example, backup and restore the data, improved collaboration, excellent accessibility, low maintenance cost, mobile hai, then services in pay per use, then unlimited storage capacity and data security. Now, what are these advantages? See, by backup and restoring the data, I mean that once the data is stored in the cloud, it is easier to get the backup and restore the data using the cloud. Improved collaboration by allowing groups of people to quickly access and share the information in the cloud. So the collaboration has been improved. Then excellent accessibility. Then accessibility, say I mean that it is going to allow us to quickly and easily access the information kahan par, anywhere, anytime in the world. Then there is low maintenance cost, like for both hardware and software the maintenance is very less. It is mobile, that means that it is allowing us to easily access all the cloud data via mobile. Then the services in pay per use model, that means you have to simply pay while using it. So it offers certain application programming interfaces to the users to access the services on the clouds and pay the charges per usage of the service. The moment how much ever is the service that you are using, accordingly you have to pay, otherwise you need not pay these things. Then there is unlimited storage capacity. It allows a huge amount of storage capacity for storing our important documents or data, like the documents, images, audio, video, in one place only. Then the data security, that is the biggest advantage of it. The security is there. The entire data is being secured and it is being managed and it is not mismanaged by anyone. But there are, if something is having pros, then definitely it is having certain cons. So what are the cons of cloud computing, or what are the disadvantages of cloud computing? First is the internet connectivity. So as you know, in cloud computing, every data is stored on the cloud and we access it by using the internet connection. Now if you do not have the good internet connectivity, you cannot access these types of data. Then vendor lock-in. Vendor lock-in is the biggest disadvantage of cloud computing. Organizations may face problems while transferring these services from one vendor to another. Like one vendor to another, when the services are being transferred, there would be certain issues. Why there are issues? Because different vendors provide different platforms, and that is going to create a difficulty while moving it from one cloud to another cloud. Then there is limited control because the infrastructure is completely owned, managed, and monitored by the service provider. So, the cloud users are having less control over the function and the execution of the services. Then, security. Although the cloud service providers implement the best security standards to store the important information, but you should be aware that you will be sending your organization sensitive information to a third party. So that is why you have to ensure that it is a trusted third party, that is, the cloud computing service provider could be trusted. While sending the data, there may be a chance that your organization's information is also hacked by hackers. So that is also a possibility. Apart from this cloud computing, there are few other things, like there is cluster computing, grid computing, and later on this term has been evolved, cloud computing. So what are these? Let us just have a look about their features, like characteristics. When I'm talking of the cluster, it is tightly coupled single system image, and it is a centralized job management and scheduling system. When we talk of the grid computing, it is loosely coupled, it is decentralized, diversity इतनी नहीं है, ठीक है, and it is, you can say, distributed job management is involved. But when we talk of the cloud computing, here we have the dynamic computing infrastructure, we have the IT service centric approach, we have the self service based usage model, and then it is minimally or self managed platform and consumption based billing. जितना consume करेंगे उतना billing आएगा. Then let's just talk about physical structure. So in clustering, a bunch of the similar or identical computers are hooked up locally in the physical location, connected with a very high speed connections. But when we talk of the grid computing, the computers do not be in the same physical location and they can be operated independently. As far as the computers are concerned, the computer on the grid is a distinct computer, it is a different computer. And when we move to the cloud computing, the computers need not be in the same physical location. Then hardware. Now the cluster computers all have the same hardware and operating systems. In grid, they can run in the different operating systems and they can also have different hardware. But when we talk of the cloud computing, the memory, the storage device, and the network communication is managed by the operating system of the physical cloud units. And the open source software such as Linux can support the physical unit management and virtualization and computing. Later on, we'll be talking of these things also. Then resources, the whole system behaves like a single system view. Here every node is autonomous. It has its own resource manager. And here every node acts as an independent entity. Applications, when we talk of this thing, cluster, the applications would be educational resources, commercial sectors, and medical research. When we talk of grid, there would be predictive modeling, engineering and automation, energy resources, medical, military visualization. And when we talk of cloud computing, it would be for banking, for insurance, for weather forecasting, for space exploration, for software as a service, for platform as a service, for infrastructure as a service. Then networking. Now here, when we talk of networking in clustered, it is dedicated, it is high end with the low latency and high bandwidth internet connection. When we talk of the grid, mostly internet with the high latency and low bandwidth internet connection is involved. And here in the cloud, we have the dedicated high end, with low latency and high bandwidth internet connection. You can say the size of scalability is 100 seconds, here it is 1000, and here it is in the range between 100 to 1000. So in any case, you can understand that in cloud computing, we have a better picture of the services that are being provided. ठीक है class? I hope I have made myself clear. In case if you are having again certain questions or queries, do let us know in the comment section class. Then computing, by computing, I mean that it is a service provisionizing model that is offering the resources to client as and when they require them on demand basis. And the charges as per the consumption would be given. There is never a fixed charge is never involved or flat charges never involved here, right? So it is a subset of cloud computing only, where it is allowing the users to scale up and down based on their needs. Clients or users or businesses acquire the amenities like the data storage, like the computing capabilities, like the applications, like the virtual servers or the hardwares, etc. things they can utilize. And in utility computing model, it is based on the conventional utilities, and it originates from the process of IT resources as well as the traditional utilities. Like earlier, we used to pay the electricity, gas, water, telephone bill. So there, the consumer has to pay the bill as per the number of units consumed, nothing more and nothing less. Similarly, in utility computing works with the same concept. You have to pay per use. The way you are using, accordingly you need to pay, right? Then the service provider owns and manages the computing solutions and infrastructures, and the client subscribes to the same and it is charged accordingly, right? Then there is a cloud computing architecture. As we know, cloud computing technology is used by both small and large organizations to store the information in the cloud and access it from anywhere, anytime using the internet connection. Cloud computing architecture is a combination of the service-oriented architecture and event-driven architecture, and it is divided into two parts. One is the front end, another one is the back end. You can have a picture over here. In front end, we have the client infrastructure, and with the help of internet, we have the back end where there are certain applications, services, runtime cloud, storage, infrastructure, security, and management involved, right? So let us just have a deep dive into it. When we talk of the front end is used by the client, as simple as that. It contains client-side interfaces and the applications that are required to access the cloud computing platforms. It includes the services like when you are browsing, you are using certain servers like Chrome's, Firefox, Internet Explorer, thin and fat clients, tablets, mobile devices. But when we talk of the backend, it is used by the service provider, whosoever is providing you the service that is actually working at the backend. What is it doing? It is managing all the resources that are required to provide the cloud computing services. So it includes a large amount of data storage, security mechanisms, virtual machines, deploying models, servers, traffic controls, etc. What are its components? Here we have the client infrastructure. Now that is the front end component, and it is actually providing you through a graphical user interface with which we are going to interact with the cloud. Then we have the application could be anything, any software or a platform that a client wants to access. Then we have a service. So what is a service manages which type of service you are accessing according to the client's requirement, right? Then there are certain layers or anatomy of the cloud. So the hierarchical structure of the cloud is known as the cloud anatomy. What is a cloud anatomy? It is the structure, hierarchical structure of the cloud. It differs from the architecture. It does not include class any communication channel on which it is going to deliver the services, whereas it is completely describing the communication technology on which it is operating. Let us just have a look. See, this is the physical or the hardware layer. This is the virtualization layer. This is the infrastructure layer, then the platform layer, and then the application layer. So when I'm talking of this in physical layer or virtualization layer or infrastructure layer, you can say that this is infrastructure as a service. When I am talking only of the platform layer, so that means I am dealing with platform as a service. When I am talking of the application layer or the web applications, there I am dealing with the software as a service. In this way, there would be a better understanding of the things. Examples would be of the physical layer, it would be data centers. For the virtualization, we have certain machines of VMs, virtual machines like VMware, KVM, Zen. Infrastructure may we have Google Compute Machine, Rackspace, Windows Azure, then Amazon's Web Services. When I'm talking of the platform, we have certain engines, Salesforce, Heroku, and Cloud Foundry. When I'm dealing with the application layers, we have Google Suite apps, Salesforce.com, GoToMeeting, NetSuite, Microsoft Office also, which is under application services. And later on, I have told you it just now, we have mentioned that Microsoft Office would be an example of SaaS only, software as a service. So the cloud is actually made of the five main elements. One is the application, then the platform, then the infrastructure, then the virtualization, and then the physical hardware. Let us just start with the bottommost layer, the physical layer or the physical hardware. So the bottommost layer is the physical hardware layer. It consists of the servers, the network components, the databases, and the storage units. That's all. When we talk of the virtualization, it is the vital technology which is allowing the cloud computing to function. It is the process of making the abstraction of the actual physical hardware resources and they are provided in a virtual manner. Like you are going to access the things but in a virtual manner. You will be using the physical things, you will using the entire source resources, but it would not be stored. You will be getting the feel, but it would be virtualized. Then infrastructure. Now this is the layer that is below the platform layer. Infrastructure also includes certain virtualized computational resources which are being provided to the users to connect to the other components. It is also allowing the users to manage both the applications and platforms to do the computations in a better manner. Then platform, it consists of the executable platforms for those who can execute it or who can develop the applications. Then the application layer, that is a topmost layer, and this layer may be used to execute any kind of the software application. Right, class? Then there is a very important topic over here, that is what is actually resource virtualization. Resource virtualization क्या है? See class, the virtualization concept provides a secure and isolated environment for any user application such that one running application does not affect the execution of other application. For example, if I am running a certain application over here, for example, if I am running Word over here and if I want to run, let's say, another application, for example, Liber Calc over here, so there would be no interaction. There would be it should feel that it is running in an isolated manner and there would be no collision among these two running applications. That is something you can understand by the concept of virtualization. It is a key technology to create an abstraction to hide the complexity of the infrastructure, storage, and networking. Now, let's say if this is functionality A, if this is functionality B, now functionality A would think that it is alone working and there is no B working, and B would feel that it is alone working and there is no such A working. And likewise, they would have the abstraction qualities and they can hide the complexity of the infrastructures. Then virtualization allows the creation of the abstraction layer over the available hardware components like the processor, storage, memory, and different environments, right? Now, it is created is termed virtual because it is similar to the real computer with an operating system, but the use of the virtual version is that it is as smooth as the user find no difference in the experience when it is compared to the real computing environment. Just now I have mentioned the example over here, right? One of the very good examples of virtualization is the hardware virtualization. In this kind of virtualization, the customized virtual machines that would work similarly to the real systems are being created. The software that runs on this virtual machine cannot directly access the underlying hardware resources. For example, you can consider a computer system that is running the Linux operating systems, and simultaneously there is a virtual machine that is running the Windows operating system. So here the Windows operating system will have access only to the hardware that is allocated to the virtual machine. So hardware virtualization is playing a very important role when we are dealing with the IaaS services. See, this is the host where we have the physical hardware, storage and the networking. Then we are moving to the virtualization. There will be virtual hardware, virtual storage and virtual networking. And then there is a guest who is getting an image of the virtual image, applications and the exact more applications, right? So virtualization technology allows the execution of more than one guest virtual machine. You can also run more than one guest machine over a single host machine. Here the same hardware resources are being shared by the all guest virtual machines, and sharing of the existing hardware resources and using the individual is actually making the capability optimum class in order to help the requirement of the number of servers and power consumptions. Then there is aggravation. Aggravation say I mean that it is going to allow to combine the resources of the different independent host machines, and it seems the guess that there is a single host, virtual host, but actually we have a variety of hosts. Then the cluster management software is the good example of the distributed computing. Then virtualization also involved emulation. By emulation, I mean that it is allowing different guest applications to run at the top of the physical machine. Here, the underlying virtualized environment is the software program, and hence it could be controlled more effectively. Then isolation. Definitely, it is enabling the guest virtual machines to run in isolation, such that no virtual machine running on the same interfaces with each other. There should be minimum क्या there should be zero collision when we are talking of the running of more than one type of guests. Then क्लाउड सिक्योरिटी बेनिफिट्स विद द वर्चुअलाइजेशन करने से आपको क्या क्या बेनिफिट्स मिले हैं? योर थिंग्स हैव बीन फ्लेक्सिबल. नाउ द ऑर्गेनाइजेशंस हैव द फ्लेक्सिबिलिटी टू शेयर द systems without essentially having the information or the data across the systems. Then data protection, it can prevent the loss or damage to the critical data in cases where the systems is compromised owing to the malicious activities. Then security against attacks, they have the ability to reduce the risks of multiple attacks in case of exposure to the methodologically isolating applications and virtual machines. Then cost is also effective over here. It is improving the physical security of the organizations by reducing the hardware requirements. Better access controls, a higher level of access control is being offered to the system and the network administrators also. So a key consideration that organizations must take into account is that their systems must be appropriately set up and they are configured to leverage the virtualization for the cloud security effectively. Modern organizations must safeguard them for the growing plethora of threats, right? So there are certain benefits also when we deal with the virtualization. Again, there are virtualization is also of two terms. It is further bifurcated. One is full virtualization and another one is partial virtualization. So what are these? Let us just talk about these things also. So class, when I'm talking of the full virtualization, so it is a technique to run an application or an operating system directly on a virtual machine without any alteration and it seems to the operating system that it is running on the real physical hardware. So it feels that your you are fully virtualized. When I am talking that you are fully virtualized class, that means you are using the entire physical hardware systems, right? And in order to achieve this, the machine manager has to provide the environment that is fully imitating the complete real hardware. In other words, full virtualization is a strategy for creating a virtual machine environment that entirely imitates the physical hardware, right class? And every software can run on the underlying devices which are executed in the virtual machine. Important benefits is that it allows the execution of the unaltered guest operating systems in isolation. These kinds of features provide extra security, and it enables for the different unmodified operating systems in the same environment, right? You can have a picture over here. Now this figure depicts the full virtualization paradigm. Now this is the host hardware. There are certain rings. Let's say this is 0th ring, first, second, third and fourth ring. Here we have the application layer. Now when we have the host hardware, we have here something known as virtual machine. Then we have the guest operating system, and later on we have the application users. So here is the binary translation of the operating system request, and here is the direct execution, right? So binary translation and the direct executions are being used together for doing what? For accomplishing full virtualization. The hardware CPU runs the non-sensitive commands at the normal speed for the full virtualization hypervisors. Hypervisors is an example of a virtual machine. So operating system related instructions are interpreted on the fly for the further use. Similar kinds of guest operating system instances can be executed on the virtualized or the real physical systems. And the full virtualization technique delivers the most required isolation and security. Further, the binary translation is another method for establishing the full virtualization that does not necessitate the hardware virtualization. It simply entails looking for the unsafe instructions in the virtual guest executable code, right? Then we have another thing also, that is para virtualization, but that is not broadly we have full and partial, but there is a short term you people should be knowing about this also. Now, in para-virtualization, it is an approach. It is also something related to half virtualization or virtual. Virt, what do we call it as the way we have told you, partial. So you can call it as a partial virtualization also, or you can also say it as para virtualization. So what is it? It is an approach for the computing devices that enables the virtual machines to get an interface comparable to the underlying or the hardware, guest hardware. Now this strategy seeks to increase the VM's performance by altering the guest operating system. So what does it alters the guest operating system? The guest OS is updated within the para virtualization. Now what it does, it recognizes that it is executing in a virtualized environment on the top of something just like a hypervisors. And it means that alongside virtualization. So it refers to the communication between the guest operating system and the hypervisor for what? Just to improve the performance and efficiency, right? Then we have a network virtualization also. Now, these are certain terms that we have given the name just for serving our purposes, right, class? So, network virtualization is the process of converting the hardware dependent network into a software based network. You are actually converting the hardware into a software based network, and the underlying purpose of this is to virtualize the network routing protocol, the forwarding, the different access addressing schemes. Further, the network virtualization will also allow every form of virtualization to create a layer of abstraction between the virtual hardware and the activities to utilize it. Network virtualization in particular allows the network functionalities like the hardware resources, the software resources to be offered as a virtual network independent of the hardware. It is used to join the VMs, partition a physical network, or merge any physical networks, right? Then we have storage virtualization. It is also referred to as software defined storage or virtual SAN, and it is the process of combining different physical massive volumes of data into a virtualized storage device. So in everything what we are doing class, we are virtualizing the things, right? We are converting the physical components in the virtual form so that it could be dealt with the guest and later on it could be sent to the users, right? Furthermore, any abstract hardware softwares could be shared or it could be pooled into online storage pools, right? Now there is an example of the hypervisors. Like when I talk of VMware or Citrix, so these are certain companies, and their hypervisors may differ. So how do they differ? Let us just have a gist of it. VMware is generally used by the small and mid-sized businesses. It requires licensed or provided per processor basis, whereas Citrix is a virtualization platform that is utilized by the individuals as well as the small and medium businesses. It is open source and it is also providing per server licensing. However, the free version is almost there and it is free for there to use. What are the features involved here over here? Features includes dynamic resource allocation, and here the features is dynamic allocation. Resource allocation is never possible over here. Now it is actually having 128 virtual CPUs per virtual machine. एक virtual machine के 128 per CPUs हैं, virtual CPUs, and they can run on either Intel or AMD intelligent devices. And in Citrix we have 32 virtual CPUs per VM, right? Only MS-DOS and FreeBSD are supported as the hosts in there. As a guest operating systems, it is supporting MS-DOS, then Sun Java Desktop, then Solaris. Whereas Citrix is hosting, it is supporting variety of host operating systems such as WinNT Server, then WinXP, then Linux, then Citrix Zen Server, and but it does not support MS, DOS, or Sunjava or Solaris. Then it supports failover or live migration, and it supports dynamic resource allocation. It does not support failover or even live migration, and it supports very few version of live migration. Then the graphic support is not exhaustive here, but here it is exhaustive and it has better support. Then BusyBox is being used by the VM server management, and here it provides almost all the features and abilities to create the virtualization environments. So if you feel like Googling a few things, you can also Google it. Like if you do not know the name of the companies, you can Google the things also. Then pooling, as the name suggests, just now I have told you, pooling means sharing resources, right? So what all the things are being shared is something known as pool. Then a resource pool is a collection of resources which are available for the allocation to the users. All types of resources, compute, network or storage could be pooled, and it creates a level of abstraction for the consumption and presentation of the resources. A large pool of physical resources is being maintained in the cloud data centers and they are presented to users as virtual services. Also, instead of allocating the resources permanently to the users, they are being dynamically provided on the need basis. And for creating the resource pools, providers must set up the strategies for categorizing and managing these resources, right? The consumers have no control or the knowledge of the actual locations where the physical resources are located, right? Like this is the pooling of the physical and virtual resources. These are the physical resources on being virtualized. These are the virtual resources. Then there are certain server pools. Server pools are composed of multiple physical servers along with the operating system and the networking capabilities and certain other softwares being installed. VMs are then configured over these servers and then they are combined to create the virtual server pools. Customers can choose these configurations from the available templates during the provisionalizing. Also, dedicated processors and memory pools could also be created. Then storage pools, they are one of the essential components which are needed for improving the performance and data management and protection, and it is frequently accessed by the users, applications, as well as they are needed to meet the requirements and maintaining the backups. Then they are available to the users in the virtualized mode. Now there are certain storage like we have the file based, block based, object based storages. What are they? File based storage means it is needed for the applications that require the file system or the shared file access. So here we maintain the repositories of the development and the user home directory. When we talk of the block based storage, it is a low latency storage needed for the applications requiring frequent access to the databases. Object based storage requires scalable unstructured data and metadata support, and it could be used for storing the amounts of data in archiving and backups. So one thing, there is a short thing that you should be knowing, because there is an unstructured data over here. What is an unstructured data class? What is a structured data and what is a semi-structured data? So these things should be known to you. When I am talking of the unstructured data, means nothing is being structured. There would be certain CSV files, there would be certain Excel files or any file which are not structured. When we talk of the structured files, that means they are structured, and they could be certain audio, video, any file. And in semi-structured, we are again dealing with the XML files. So out of these things, only the unstructured data is the thing that is being dealt here when we talk of object-based storage. Okay? Then there is another type of pool known as network pools. That means anything that could be shared over network. So the resources in pools that are connected to one another or to the resources from the other pools by the network facility is a network pool. It could be further used for the load balancing, link aggregation, etc. They are composed of the different networking devices like the gateways, switches, routers. Then the virtual networks are then created from these physical networking devices, and then they are offered to the customers. Customers can build their own networks using these virtual networks. Generally, the dedicated pools of the resources of different types are being maintained by the data centers. They may also be created specific to applications or the customers, right? Hierarchical structure could also be used to form parent child sibling nested pools just to facilitate the diverse resource pooling or resource sharing requirements. Then again, there are two types of clouds. One is a single tenant, another one is a multi-tenant cloud, and which you should use. So let us just talk about it. When operating in the cloud, one of the key decisions to make about is which type of architecture you are going to adopt for your business and the customer data. Why is it so? Because choosing the cost effective architecture is the key for building a profitable SaaS software. So, a single tenant and multi tenant cloud environments are the options to consider, and both of these architectures have the security and the privacy implications, right? There is also the issue of cost, which is varying differently. Just have a look, class. When we talk of the single tenancy, we have the different database, we have the different applications, and each one is being used by the different users. But in multi-tenancy, we have the single database, we have the single app, and that is being shared among multiple users, right? So in single tenant cloud architecture, it is one where a single software instance and its supporting infrastructure or database is serving only one customer. So in a single tenant environment, all the customer data and interactions are separate from one another, and they are not housed in the same database, and there is no sharing of data also. And in a multi-tenant, there is one where a single software instance and the database is serving the multiple customers. Now, the real estate analogy is often used to explain the single tenant versus multi-tenant cloud architecture. Now, in single tenant, each customer lives alone in the single apartment building, which has its own security system and it facilitates and is completely isolated from the neighboring buildings. But in multi-tenant, the tenants live in different apartments inside the single apartment building only. They share the same security system, the same communal facilities, and each tenant has the key to their respective apartments so that their privacy is guaranteed within their apartments. However, the activities of the fellow tenants are more likely to have impact on the comfort in the building. Most startups opt for the multi-tenant setup, which means having one big database that houses all the customer data. With the right security systems in the place, the customer data stays private. While customers cannot see each other's data, they do live in the same database and the same computer processes of the data. They are not segmented in some way. For example, let's just talk of a particular society. Like we have a different flats. Now one flat is completely isolated with the other. It is completely isolated with the second, third, fourth, something like this. So that is something known as the single tenancy. But when we deal that supposedly there is a single house, some type of chawl. Let's just talk about a chawl or some jhugi. What is happening? There is a single tenant, and there is a single owner, and there are a variety of tenants. Now the tenants are obviously there are certain flats over here. They can see each other's activities. The activities could be seen, though it is not going to affect you people, but in some or the other way it is going to affect you. But in most startups we are still opting for the multi-tenant setups, right? Then what are the benefits and the drawbacks of the single tenant cloud architecture? Data security. That is the benefits, definitely. The benefits is data is secured. Each customer's data is isolated, minimizing the risk of the data breach. Customization options are available in the single tenant as compared to the multiple tenant because each customer has the dedicated software and hardware. Then it is portable. It is easier to migrate the data from a single tenant architecture, and the most obvious reason is that there is simply less data to handle as compared to multi-tenant. The data is also less. Also, since the data store contains only the data for the single customer, the team has to less worry about the complicated scripts. Then what are the disadvantages? Complex setup and management. You have to deploy an instance and the set up a database for each customer, and as the client grows it becomes difficult to manage more applications, right? Higher costs, then inefficient resource usage. Resources are also likely to be underutilized, leading to the inefficiencies. We do not want something to be underutilized, we want it to be utilized properly. Since the customers do not have the same usage patterns, allocating the same amount of resources to each will result in using all of these resources while other is going to use nothing. Somebody is using completely the entire resource, other is using nothing, so that also we do not want. So these are certain cons as we talk of the single tenant cloud architecture. Then the benefits of multi-tenant, easy deployability. Consider a team of two people who are building a new startup. Now it would be too much work for a team of two to serve multiple clients using a single tenant. So while it is doable, it would require a lot of effort. So if they adopt a multi-tenant system, so they can reach for the tools that are being provided by the cloud service provider, and they can build the application faster. Then efficient resource usage. Unlike the single tenant where the resources are underutilized, here the available resources are used maximally. Then reduced cost. Now they can share the environment, so the application is cheaper to build and maintain. Maintenance and management costs are also being shared by the customers. For example, a single Dynamo DB data table could hold all the application for millions of customers, right? As we talk of the Amazon also, but it is also having certain disadvantages. The first disadvantage is greater security risk, and the second is lack of cost visibility, right? So in multi-tenant system, the risks are higher because the resources are shared by multiple customers. If one customer's data is compromised, it is likely that it is going to affect the others also. Then lack of cost visibility. In comparison to that, each customer has its own database. It is much harder to separate the costs in multi-tenant system. Then When to use single tenant and when to use multi-tenant architecture is the most important question that may be asked. So a single tenant architecture is suited for the specific industries or the sectors where there is strong privacy and security concerns are around the customer's data. For example, let us just talk of the healthcare and the finance industries. So in healthcare, for example, the applications must meet the requirements while dealing with the patient information. So each hospital may need to have their own data centers on site to ensure the compliance. And the same applies to the types of financial data. Then most consumer facing applications are best built using the multi-tenant applications. The cloud itself is multi-tenant. Cloud service providers such as Amazon services, they use the same hardware for various customers under the covers. They have a different Amazon account. They have the same computers process customers information. And the last topic for the day, that is VM sizing, virtual machine sizing. What is it? So it is a process of estimating the amount of resources that a virtual machine should be allocated. कितने resources एक VM utilize करेगा उसको एक estimation करना is something known as VM sizing, and it is the objective its objective is to make sure that the VM capacity is kept proportionate to the workload. For example, if the workload is for 3 hours, then accordingly let's just say that 30 resources would be shared and that would be estimated. And the estimation is based on the variety of parameters specified by the customers also. So it is done at the beginning only, and in the dynamic provisioning it could be changed also. Now this is when we are talking of the static provisionizing, but in dynamic it could be changed also depending on the workload. And there are two ways to do the VM sizing. One is individual, another one is joint VM sizing. Now in individual it depends on the previous workload patterns. The resources are allocated accordingly, right? And in joint, in this case, the allocation is done in a combined way. Here the resources are being assigned initially and then they are reassigned to the another VM hosted on the same physical machine. And then hence you can say that it is leading to the overall efficient utilization of the VM. Right, class? So this much is all for your syllabus, class. This much is more than enough. Let's just talk about the things. So we have dealt with a lot many things, but for your syllabus, particularly for this MSE 030, this much is, I can say that this much is more than enough when you be able to do these things. I hope I have made myself clear. In case if you are having any doubts, please do let us know in the comment section. And class, we are working very hard for preparation of these lectures. We would want you people to please do like, share and comment and share it more and more, so that the people who are not available of the channel should who are not aware of the channel should be aware of the things that here we have a platform where the Ignou students can directly have a look and can understand the things, and they can utilize these options and can perform well in the examinations, right, class? So in case if you have any queries, do let us know in the comment section what all we have done, class. Just for a brief, just I am giving what is a cloud computing that we have dealt, कि cloud computing क्या होता है. Then in cloud computing, three things you should be knowing: IaaS, PaaS, and SaaS. That is the second point. What are these things? Then next thing you should be knowing that what are the deployment models. Actually there are three models. One is public, private, and hybrid. Sometimes community is also involved. That is the fourth point that we have done. Then what are the characteristics of cloud computing? What are its features? Then what are the advantages of cloud computing? Sixth point. Then what are its disadvantages also? Everything has advantage and disadvantage. Then there is something known as cluster and grid computing also. What are these? Now that is the eighth point. And then we are having the utility computing that is being involved. Then how the cloud computing architecture is being explained. Then what are the layers or anatomy of the cloud? Cloud has certain anatomies also. Then what is resource virtualization? Virtualization, what is it actually? Then now that is the 12th point only when we deal with the virtualization. Then what is pooling and what are the variety of poolings that you people should be aware of. And after doing the pools, the last thing was what is a single tenant and the multi tenant. So in 14 points we have understood the things, and another point that was VM sizing also. 15 points you can say that we have understood or we have completed or we are thorough with the complete cloud computing syllabus. So that is all for today class. Thank you. Please do like, share and comment, and stay tuned with us. If you have any doubts, do let us know in the comment section. And if you want certain few lectures also on a particular topic, that also we expect you people to write it in the comment section. Thank you, class.